Hello everyone, myself Mohit Gangwar and this is my project video for the theory course ELL101. I have chosen the topic of a regulated DC supply, for example the mobile chargers that we use in our daily life. In this video, I will be explaining the working of a regulated DC supply. The main components of a regulated DC supply consist of a capacitor, a few diodes, a step-down transformer, and an IC means integrated circuit 7805. The working of a regulated DC supply can be broadly divided into four steps. Number one, stepping down the AC voltage. In this step, the provided input voltage is reduced using a step-down transformer. Number two, rectification. In this step, we remove the negative part of the alternating current using a full wave rectifier. Number three, filtration. In this step, we use a capacitor to make a more efficient DC supply. And the last, voltage regulation. In this step, we use a voltage regulator IC 7805 to provide a regulated DC voltage. This is the flow chart for the working of regulated DC supply. Now I will be discussing about all these steps in detail using the circuit diagram. So this is the complete circuit diagram of a regulated DC supply. As we can see, it consists of a transformer, a few diodes, capacitors, and a IC 7805. As we are converting 220 volts AC into a low volt DC supply. So to achieve it, we will firstly convert the 220 volt AC into a low volt AC. For example, in case of mobile chargers, we finally need a 5 volt supply. So we convert it into 9 volts AC. For that, we use a step down transformer to reduce such high voltage, which is highlighted in the circuit diagram. As we know that the transformer, there are primary and secondary coils which are responsible for the reducing of voltage according to the ratio of their number of turns. The selection of proper transformer is very important here. The current rating of the transformer depends upon the current requirement of the load circuit, which will be used to generate the DC current, and the voltage rating should be more than the required voltage. For example, if we need a 5 volt DC finally, as in case of the mobile chargers, the transformer should have at least rating of 7 volts in this case, because the IC 7805 which we are using later needs 2 volts more. Moving on to the second part, rectification. Rectification is the process of removing the negative part from the alternating current and producing the partial DC one. This process is achieved by using a full wave rectifier highlighted in the diagram. It consists of 4 diodes as shown. As we all know that diodes only allow the current to flow in only one specific direction and does not allow the current to flow in the opposite one. So here the 4 diodes are arranged in such a way that they rectifies the negative part of the alternating current into positive one. It is achieved in the following manner. In the first half cycle of the AC diode, D2 and D3 shown in the circuit diagram are forward biased and the diode D1 and D4 are reverse biased. While in the second half, means the negative half of the AC, diode D1 and D4 are forward biased and diode D2 and D3 are reverse biased. This combination converts the negative half of the AC current into the positive one as shown in the diagram. In this way, the negative part of the alternating current is removed and partial DC current is produced using the full bridge rectifier. Moving on to the third step, that is filtration. As we have seen earlier that the output after the second step, that is rectification, is not a proper DC current. Rather, it is an oscillating output and has a very high ripple factor. We don't need that pulsating output. So to rectify it, we use a capacitor denoted by C1 and highlighted in the circuit diagram. This capacitor works in the following manner. It charges till the waveform goes to its peak. and discharges into the load circuit when the waveform goes low. So when the output is going low, the capacitor maintains the proper voltage supply into the load circuit, and in this way it creates a DC current as shown in the diagram. In case of the mobile chargers, the value of this capacitor is roughly around 1000 microfarad. Moving on to the last step of the regulated DC supply, voltage regulation. In this step, we use a voltage regulator IC7805 highlighted in the diagram to provide a regulated 5-volt DC supply. Here, the voltage should be 2 volts more than the rated output voltage for proper working of this IC. For example, as we stated earlier, in case of mobile chargers, we need a final constant supply of 5 volts. So in this case, the input voltage should be at least 7 volts. Although the IC can operate easily in the range of 7 to 20 volts, but minimum requirement is 7 volts. The voltage regulator provides a proper regulated DC supply. Also, we have connected a capacitor C2 to the output of IC7805. We have done so to eliminate the noise produced by transient changes in the voltage. So in this way, we finally get a regulated DC supply as per our convenience. In case of mobile chargers, it is supposed to be 5 volts. In fact, DC supply can also be used as a power source for digital circuits, breadboard circuits, ICs, microcontrollers, etc. etc. Similarly, we can also build 6 volt, 10 volt or any other constant DC supply by same concepts. We just need to use proper transformer, capacitor and voltage regulator IC. The basic concept in any of these will remain same as discussed. We just need to arrange the new components to get the required output supply. Thank you.